Hi guys, so this video is actually specifically targeted at a question about clocks. So this video is about kind of like using your knowledge of angles and measuring arcs and stuff like that. So I've got some videos about arcs and stuff like that on my channel, so check it out if you haven't already. But this is actually one of those kind of like higher end questions that I wanted to step through very slowly. And it does require a bit of thinking, or math does, but I think when you look at the question, you kind of just like, I've got no idea how to even approach it or anything like that. So that's what I wanted to do for this video and actually break it down with you as a, all together. So let's have a read. So our clock has an hour hand of length 8 centimeters and a minute hand of length 12 centimeters. Calculate the distance traveled by the tip of each hand in half an hour. All right. So there's two different hands. So it's basically asking two different questions. One, how far has the tip of the minute hand moved, and how far has the hour hand moved in half an hour. Sorry. So have a think. You've got a clock, right? You've got a clock, and there's always that small hand, which is your hour hand, and then you've got the longer one, which is your minute hand. So the minute one, so if you think about it, if that's like 12 o'clock there, then you've got 3, 6, and 9. Oops, that's a horrible 3. But yeah, so to start from here, so let's say it was 1 o'clock, and for it to get back to here, it has to be an hour, right? So there's a whole hour. It actually travels 360 degrees. I'm just going to focus on the minute hand for now. So I'm going to write minute hand. So the minute hand in 1 hour, if you think about it, it actually travels 360 degrees. Am I right? So one whole revolution. So 1 o'clock to 2 o'clock, the minute hand has to go back to the 12. So 1 hour, it travels 360 degrees. And based on that, I can probably figure out how far it travels in 30 minutes, right? So half of that. So half in half an hour, so you divide it by 2, divide this side by 2, you'd get 180 degrees. Okay, so that's how many degrees is actually moved. So realistically speaking, I'm trying to find, if this is like my minute hand there, I want to try to figure out how far it's moved from 1 o'clock to like 1:30. Okay, so think of it like a semicircle. Let me try draw a better picture for you. Okay, so it's traveled 180 degrees. Okay, and if you think about it, right, the radius, which is talked about here, so the length of the minute hand, which I'm looking in particular, is 12 centimeters. So 12 here and 12 here. So the total length is 24. All right. So let's try to figure out how far it's at, because realistically, we just want to know how far from the tip of the hand. So that's basically like the arc length. So I'll do that in red for you. So that's what we're trying to find, this arc length, which is a part of the circumference. So we know we're actually using the circumference formula, so 2 pi r. All right, so what I'm going to do is I'm going to write 2 pi r, but we're trying to find a portion of that. We're not trying to find the full circumference, we're only trying to find half of it, right? So we're only like really dividing it by 2. So really we're just trying to find pi r, right? So r in this case is what? So we've got 12 pi. Oops. 12 pi. Okay, so that's my first part here. Another way you could have approached this is kind of theta over 360 times by 2 pi r. And you would have noticed that it's just 180 divided by 360 times 2 pi r, or which is 8. Sorry, not 8, 12. And so in this case, that's basically half there. And then that cancels out with that, so that becomes 12 pi. All right, so we figured out that minute hand. So let's try to do that other side. Let's try to do the hour hand. Okay, so let's think of it in the same way. And you got to remember that that hour hand does not move that much. Like if you think about it, so it only moves really kind of like from 1 to 2 o'clock. So it doesn't actually move very fast. It doesn't, go through 360 degrees in 1 hour. How long does it take for it to get back to 1 o'clock? So there's 1 o'clock, what time? It takes another 12 hours for it to get back to 1 o'clock. So like 1 a.m. to like 1 p.m. That's 12 hours. So that takes 12 hours for 360 degrees. Okay, so then that means, okay, well, how much in 1 hour? So 1 hour means we have to divide it by 12, divide on one side, divide it by the other side. So it takes 30 minutes. Oh, sorry, 30 degrees. So in this case, I want to try find out in half an hour. So I'm going to halve that. So in 30 minutes, divided by 2, it's about 15 degrees. So we're going to use that same concept as that, you know how I talked about a little bit earlier, theta divided by 360 times by 2 pi r, because we're trying to find the arc length. The arc length is a part of the circumference. So I'm going to go 15 divided by 360 times by 2 pi, and my radius in this case is not 12, but it's actually 8. So that's the hour hand. So my hour hand is 8. I'm going to simplify this down a little bit more. So go 15 divided by 360. That can go both into 5 and also 15 as well. So that can actually be simplified down to 1 over 24. Times by 8, 2 is a 16 pi. 16 over 24 can definitely be simplified. So that can be divided by 8. So 2 and 3. So that just ends up being 2 over 3 pi. So those are our two answers there. So you can see that I've used exact values in this question where I've broken it down. So let's go back to the beginning. I've got the lengths. I found out how many degrees the minute hand moved or the hour hand moved. And from there I found out how long it took for the whole revolution, and therefore found how much it would move in half an hour. So, and then from there I substituted into my formula, or just basically broke it down in a way where it makes sense. I'm only finding half of it for the minute hand, or I'm actually finding 15 over 360, or a portion, a small fraction of how far it moved. Right, so it only moved 15 degrees in half an hour. Yep, and after that, I just broke it down and didn't solve it, so I didn't put it into my calculator. I just left it in terms of pi. I hope that video was really helpful for you. It's a bit of a strange question, and I know that people would probably ask a lot of questions about it. So let me know if you have any other feedback or any other questions, and I look forward to reading them. Thanks, guys. Bye.